Alright, the stream is up. We'll give it a couple minutes before we can get some people in on this. Also gotta make sure I can see the chat box. And I don't know why it keeps on changing it to a different name. But oh well. Okay, so I guess I'll kind of just start by prefacing that I'll do my best to answer all the questions. Ideally, I would like to finish the entire packet, but just kind of making sure we do have, 2 days before your test, so you'll have time to watch this video, you'll have time to come in and get help from me tomorrow, even though I won't be there. You guys can still email me, ask me questions, and yeah, should be pretty straightforward, I'd like to think. So with that being said, I'm not seeing anyone on the... Oh well, we'll go ahead and get started, and then people can catch up. So right there, number 1. Actually, why is my thing not working now? Huh. Technology, guys, this is why we love it. Give me a second. Nope, that's the wrong one. Interesting. Okay, now that's working, but if I hide it, I guess I have to keep it up. Okay. Cool. I think we should be good now. All right. Where'd my chat box go? There we go. Okay. We kind of did number 1 in class, but again, just making sure we understand the types of triangles we have. Isosceles triangles means 2 of your sides are going to be congruent, as well as their corresponding base angles. So in this case, we know that that angle is 62 degrees. So then what we can say is 62 plus 62 plus x equals 180. Alright, so then we got x equals 56. Now if I'm looking at the other triangle, same idea again. Gotta go ahead and set up the fact that, again, the isosceles triangle, that means that this angle is congruent to this angle. So we're going to go ahead and say that 2y plus 2y plus 88 equals 180. So then I believe we're going to get 4y equals 92. So what is that, 23? Yeah. So there we go. Pretty straightforward, clean, and right to the point. Gonna cheat a little, shrink that down. Okay. Number 2. Again, I kind of looked at this in class as well, but doesn't hurt to revisit. So the overall picture we have here is an isosceles triangle. So again, I know that these base angles are congruent. I can spell. There we go. Now, those markings up there for x tell us that this angle and this angle both have a value of x. If I isolate this corner, the total angle measure there is x plus x, which is 2x. So then, if I want to find the measure of x, I can say 2x plus this 75 plus angle y. Well, we already said angle y was 75 degrees, and that's going to equal 180 degrees. 2x plus 150 equals 180, 2x equals 30, x equals 15. And there you have it. Number 3. You've got these two lines that are parallel. So again, you see parallel lines, we should be thinking any of our parallel line postulates. We have another isosceles triangle in here. I may or may not be emphasizing the fact that we really need to know our isosceles triangles. You know, no biggie. Sorry. So if we take a look at this, we can say that I don't know what these angles are, but I know they're supposed to be congruent. Let's pick a different color. So I can say, let's just call them Z, because why not? Or even simpler, I know some of you guys don't even want to use the letters, so let's just say that I know that the angles inside all have to add up to 180. So if I take away the 52, right, we should get 128. Well, since those two angles are congruent, let's split them in half. So there we get 64 degrees. Now, we can go ahead and use the fact that this angle plus angle x form a straight line. Since they form a straight line, we can say that those two angles form a linear pair, which then means they're supplementary. They add up to, again, 180 degrees. So then that's going to give us a nice 126 degrees. No, I lied, 116. Alright. Now that's x. Finding y? Not a whole lot of work, because if I kind of erase this for a second and look at the fact that my parallel lines form a letter Z here, that means that this angle here is congruent to this angle here. Well, how do I know they're congruent? They are alternate interior angles. So that means that if that angle was 64, angle y will also be 64. Angle, or number 4, we have two isosceles triangles. They're both oriented a little differently. We've got to be careful about that. On the left triangle where angle y is, those two base angles are congruent. And in the triangle on the right, we know that this angle is congruent to this angle. So for the right triangle, which we can solve for x, we can say x plus 50 equals 180 degrees. So then again, just by solving, we should get x equals 65 degrees. Now going back over for y, we have to remember that this 50 and this angle here are formed by the two lines intersecting, which means that they're vertical. They're across from each other, and that means they're congruent. So that means this is 50 as well as this. So we're going to have 100 plus y equals 180 degrees. So y is going to equal 80. Number 5, again, we've got two parallel lines. And what's kind of nice about this picture is we have this transversal here going on. So even without looking at the triangle, we can already see, hey, I've got corresponding angles here. And we know that corresponding angles are congruent. On top of that, once we actually consider the triangle, let me use green. Once I actually consider the triangle, well, again, it's isosceles because of these two congruent marks. So that means, again, my base angles are congruent. So now I know that x, which we said was 65, I totally can, plus 65 plus y equals 180 degrees. So therefore, y equals 50. Number 6, got to be careful because we don't want to think, okay, we've got only two angle markings. We have nothing to do with the sides. And then again, the big issue is you see those three and you might be thinking, oh, let's add them all up. Set them equal to 180. Well, first off, none of those equations go to angles. They all go to sides. So therefore, we cannot even use or even think about 180. However, we're going to kind of go backwards. And here's what I mean. We know that in an isosceles triangle, usually we're given the two side markings. Then we make the markings of, oh, our base angles are congruent. Well, now we're going backwards. Now we're saying, hey, oh, that did not work out. We're saying, what is going on? There we go. Now we're saying, hey, we're given that the base angles are congruent. Now their opposite sides are congruent. So we're going to do those markings here and here. Since those are the only two sides that are being marked, those two sides have to be set equal. So then we can solve this. So let's see here, if I take away 2x from both sides, and I go ahead and add 5 to both sides, we can go ahead and say that we have 2x equals 12. So therefore, x equals 6. Now, right now, all these problems are just saying solve for the variable. If I ask you to go back and find the length of the sides, you would just take that x, plug it back into your triangle. Alrighty. Ooh, here we go. Got another isosceles triangle. Yay! But hold on. I didn't give you any angles inside. Well, one thing we know, again, these two angles form a linear pair. So that means that that mystery angle is going to be equal to 180 minus 110 degrees. So I believe that's going to give us a nice 70. Again, going back to the isosceles triangle idea, we know that this base angle is congruent to this base angle. So those are both 70 apiece. So we're saying 70 plus 70 plus x equals 180. So therefore, x equals 40 degrees. Number 8, we got a lot of markings here, but we got to follow them. We've got this triangle here, and we got this triangle here. Now the yellow triangle is an equilateral triangle. That means all 3 sides have the same length. As a result of all 3 sides having the same length, all the angles have the same measure. It's going to be important that you remember that in an equilateral triangle, all your angles are going to be 60 degrees. Because again, if they're all congruent, you take that 180 degrees divided by 3, you get a nice solid 60. So we know x equals 60, and that can go into each of your corners. Now again, going back to the linear pair idea, we look at that top corner where the yellow and the green triangle meet. This angle here, let me try a different color. This angle here, right? So the 60 degrees plus that top angle is going to add up to 180. So let's say 180 minus 60 gives you 120. So this angle here is 120. I want to find y. If we take that picture of that green triangle and kind of turn it on its side, then that means we again have another isosceles triangle. So that angle is y. This angle is also y. So going back to this, we can say that 180 minus the 120, and then take the 2y and divide both sides by 2. All right, number 9. We have an angle that is outside of our triangle. This is our exterior angle. And if we look right here, we have these 2 angles that are away from this corner. If they're away from that corner, we say that they are the remote angles. So what we can do is we can say that the exterior angle equals the sum of the remotes. Well, the exterior angle is x. The sum of our remotes is 65 plus 32. So therefore, x is 97. Number 10 is kind of going back to those same types of triangles that we did in class with the exterior angle theorem, but we're still going to need to make sure that we remember how to do that. So I'm looking at this and I'm saying, hey, I know how to find angle z without doing any crazy work. Because again, z is outside of this triangle here. And the remote angles to z would be 72 and 22 respectively. So we can just say z is equal to 72 plus 22. Now this is going to be helpful because if I want to find y, I've already kind of done 90% of the work. Now I just need to do 180 minus the 94, because again, y plus 94 form a straight line. So we have 180 degrees again. So then I believe we're going to get 86. Now we can solve for x in a couple of ways. We could work with this triangle that's on the right side here. We could say, hey, we know all 3 of those angles will add up to 180 degrees, and that is fine. You can totally do that. Not a problem at all. The other way we could do is we could try to look at the big triangle and then try to set that equal to 180. But I'm going to tell you right now that this will actually be much easier to do if we try the triangle. There is one more method I'll show you in a second, but let's try with the triangle first. So 94 plus 19 plus x equals 180. So let's see, 9 and 4, that's 13, plus the 10, so 113, plus x. So then x is going to equal, after I subtract the 113 from both sides, 67 degrees. Now an alternate way of doing x is I could say that since I already have my exterior angle of 86 degrees on the y, I know that y is supposed to equal the sum of the two remote angles. So I can also do it using this approach. So y equals x plus 19. Now this is again me pretending that I did not just do this. Okay, this is our alternate method. So I know what y is. 86 equals x plus 19. So if I go ahead and subtract 19 from that, I am indeed going to get 67. Alrighty. What is the shortest side? Now again, I didn't give you a picture for this triangle GIV, so let's go ahead and draw the triangle. Oh, I know you guys are going to be mad at me if I don't do this. Alright, so I'm going to label this left side G, this I, and B. Label what you know. 4x minus 12, 3x plus 10, and then lastly we've got 5x minus 10. Okay, so clearly we have a triangle. I have 3 different angles, so I need to add these up and set them equal to 180. Yeah, let's use a different color. Okay, so now at this point I'm going to go ahead and combine like terms. 4x, 3x, 5x. So I'm going to get 12x. Then I've got my positive 12, my positive 10, and my negative 10. The positive 10 and negative 10 are simply going to cancel out. They're going to become 0. So all I'm left with is plus 12. Yeah, I started using blue, didn't I? Alright, so now let's take away 12 from both sides. Alright, and then now we're going to go ahead and divide both sides by 12. Now, I'm not going to be allowing us to use calculators, so let's be smart about this. I have 12. 12 is going to go into 16 one time without going over. Well, there's a leftover of 4. So I know that it's going to go in once, leftover of 4. How many times would 12 go into 48? 4 times. 4 times 12 is 48. So that's going to be x equals 14. So now looking back here, we're saying what is the shortest side? The shortest side is going to be opposite the smallest angle. So we're going to want to find which of these 3 is the smallest. If I go ahead, yeah, I'll do the work over here. So angle G is going to equal 4 times 14 minus 12. 14 times 4 is 56 minus 12. So we have 44. Angle I is 3 times 14 plus 10. So then again, that's going to be 42 plus 10. That gives us 52. Just double checking to make sure. Yeah, that's right. All right, and then angle V, last but not least, 5 times 14 minus 10. So we're going to have here 70 minus 10, which is equal to 60. Okay, now let's go ahead, take all this work. Wait, something's not right, I think. Yeah, something doesn't add up. Too bad I can't live edit this. Oh well. Let me make sure I plug them all into the right ones. Yeah, I did that right. Okay, so why do I feel like that's wrong? Yeah, that can't be right. Yeah, those 3 angles don't add up. Wow, this is kind of embarrassing. Yeah, what's supposed to happen, guys, this is why I'm kind of freaking out here. These are the 3 measures of my triangle. They're supposed to add up to 180. So maybe I made a mistake over here. So 4x minus 12. Ah, of course. All right, so I found my mistake. Gonna fix it. Yeah, I don't know why I even helped someone out with this earlier. Like, seriously. Good job, Mr. T. Let's see if I can salvage as much of this as I can. Cool. All right, so minus 12, minus 12. So that means we're going to actually add 12 to both sides. Awkward. So that's 192. Again, we can still do the same technique. 12 goes into 19 one time. Well, it's going to go with a leftover of 7. And then how many times does 12 go into 72? 6 times. Now let's try that. All right, Mr. T, let's not embarrass ourselves anymore. So 4 times 16. So that's going to be 64 minus 12. And that's going to give us 52. All right, now we're getting there. 3 times 16. So that's going to be 48 plus 10, which is 58. All right, now we're getting much better. 16 times 5, that's going to be 80 minus 10. So that gives us 70. All right, now looking at this, all of our angles, all 3 of them add up to 180. That was totally embarrassing. Oh well. So we have our angle measures. We're going to put them in. So G is right here, 52, 58, and 70. Now again, the shortest side is going to be opposite of our smallest angle. So that means that our shortest side here for this triangle will be side IV. I think I made the joke to someone who said, Mr. T, does the order of the letters matter? And I said, no, unless it's Roman numeral, then it does matter. Bad joke, I know. Alrighty. Smallest angle in triangle ABC. It's going to be opposite the shortest side. Boom. Angle B. Okay, I don't know what happened there. There we go. List the sides in order from shortest to longest. I'm going to be looking at my angles and look at their corresponding sides. Alright, so again, looking at the order, shortest, longest, I'm going to write the angles in order of smallest to biggest. And then what I'm going to do is I'm going to say, hey, that 50 is pointing at side JL, or LJ, whichever you want. The 64 is pointing to the JK. And then lastly, 66 is pointing to LK. All right. And so there is our sides listed in order. Naming the shortest side. We had a fun one trying to explain this in class, and I understand that this is somewhat of a difficult concept. So one way that we could try this is we could make up numbers. But before we do, we need to find all of the angles that are missing in our triangle. We got to find angle B, and we got to find that corner of angle EMR. Okay. So you can do this along. Let's say angle B plus 53 plus 64 equals 180. So I believe that's going to get us 63. And then on our other triangle, we're going to have, I don't want to say angle M, because angle M, we don't know if we're talking about this angle or this angle. So I'm going to give that a variable. Let's just call that X. Why not? So we're going to go ahead and say X plus 71 plus 47 equals 180 degrees. So then this gives us a nice 62 degrees. Now I'm like really conscious about my work. You gotta make sure I got it. Yeah, that's 11, that's 18. Okay, we'll go with this. 64, not 63. For which one, Elijah? I'm glad you're online, by the way. Yeah, because that should be 63, 180 minus. Did I write a number down? No. For that triangle, I've got 53, 64. Oh, I was like, what are you talking about, Elijah? And then I'm just double checking that. 71 plus 47, that should be 118. 6, 7, 8. Okay. Yeah, no, that should be right. X equals 62. Okay, I must be really losing my marbles. Okay, so again, we've got these two triangles. One method that the other teacher I work with was saying was, let's make up numbers for these sides. So on my left triangle, I know for a fact that we're looking for the shortest side. So let's look for the smallest angle in the left triangle. I've got a 47 degree there. So let's say that that side has a length of 1. So with the 62 degrees, since the angle is bigger, its opposite side must be bigger. Let's just pretend that's a 2. Now 71 is bigger than those two, so let's say that has a side length of 3. This is not to scale, but if we use ridiculously big numbers, then it just doesn't work out. Now if I look in my other triangle, the 63 is pointing to angle 1, but 63 is not the smallest angle. 53 is the smallest angle. So since 63 degrees is pointing to the side that has a length of 1, 53 has to be smaller than that. So we could pretend that's something like 0.5. So then in this case, which side is going to be the shortest side? It's going to be this side here. So we're going to have RB. All right. Now we're looking at the rest of our work, which is number 15. Now, the key thing to remember here is that in our problems that we kind of did on our quiz, we said which 3 lengths could be the length of a triangle. So remember that we're saying that A plus B has to be greater than C, where A and B are your shortest sides of your triangle, and then C is your longest side. This is part of what we say is the triangle inequality. So if I look at A, here are my 2 shortest sides. So I say, hey, 5 plus 12, is that greater than 17? Nope, so that doesn't work. If I look at the next one, I have 9 and 11 as my shortest sides. Is 9 plus 11 greater than 22? No, it isn't, because 9 plus 11 is 20. 20 is not greater than 22. So this one is also a no-go. Right over here we have 10 and 15 being my shortest sides. So is 10 plus 15 greater than 24? Heck yeah, it is, because we've got 25 greater than 24. Boom. Now, just for clarification, if we look at the next one, 7 and 6, I don't think 7 plus 6 is greater than 21. So therefore, that one's a no-go. Further evidence. Now on 16, we're doing the exact same thing. However, it says which 3 lengths cannot work. So in other words, we're going to find the one that fails us. So here we go. 2 shortest sides, 17 and 14. 14 plus 17, I'm pretty sure is greater than 23. So even though that one works, we're looking for the one that does not work. All right, so that one's an X-nay. The next one we've got our 2 shortest sides of 11 and 11, which I know for a fact that 22 is greater than 12. So even though that worked, that was not what we were looking for. Next one, we've got 5 plus 7. And indeed, 12 is greater than 8. Now don't just circle the last one just because it was the one that worked. Let's show it. 6 and 10. 6 plus 10, we're trying to see, is that greater than 21? And unfortunately for us, 16 is not greater than 21. So this is the one that we want to select. 2 sides of the triangle have these lengths. What are the possible lengths of our third side? Again, just like we did on our quiz, we take our max value by saying 10 plus 15, getting us 25. We find that our minimum value is going to be 15 minus 10. Now again, your answer is going to be one of two forms. It's going to be the inequality, or you can say it as a short sentence between 5 and 25. Either or. In terms of explaining, all we're really doing is using our triangle inequality. That's really all we're doing. All right, the fun one. State whether these triangles are acute, right, or obtuse. So again, just a quick recap. The acute is when our alligator points to the left, right if they're equal, obtuse if it points to the left. If we organize the letters for acute and obtuse, we can then use this to kind of help us. Are we going this way or this way? Right? We don't know which way until we check. All right. Two shortest sides, 3 and 4. 3 squared plus 4 squared. I'm comparing that to 6 squared. So I've got 9 plus 16 and 36. I don't think 25 equals 36. Pretty sure that it's less than 36. So that means this triangle is obtuse. $19. I know you guys love radicals. That's so rad. Well, you just got to remember that the square root of 5 squared is going to leave us with the plain old 5. Well, in this one, 8 is bigger than 5. So that means this is an acute triangle. Number 20, got to do that Pythagorean theorem. We're going to check. Is this going to give us a different one? Square root of 10 squared, that's going to be just a nice old 10. And would you look at that? 10 equals 10. So therefore this is a right triangle. Speaking of the Pythagorean theorem, we're going to use it on this right triangle. Whoa! All right, let's do this. A is 4 and B is 5. We're going to find C. 4 squared plus 5 squared equals C squared. So let's see here. 16 plus 25, that should give us a nice 41. Now if I try to get C by itself, we're going to need to take the square root. So then C is going to equal the square root of 41. Now I say leave it in simplest radical form. If I look at the number, 41 is a prime number. Therefore that means that I cannot break it down besides 41 times 1. So as a matter of fact, we're done. All right, 16, 20, we want to find B. So in this case, I'm missing a leg. So 16 squared plus B squared is going to equal 20 squared. 16 squared is 196. No, wow. Yeah, no. 16, wow. Let's try 256. Now right here we're going to take away 256 from both sides. I should probably take off the auto shape. So then we're going to get b squared equals 144. Pretty sure after taking the square root there, b is going to simply give us 12. Alright. Last but not least, a squared plus b squared equals c squared. So rad 5 squared plus 2 rad 5 squared equals c squared. So then we're going to be left with 5 plus, now this 2 rad 5, I know some of us are a little stumped on how do we actually square that. Well, if we say 2 rad 5 squared off to the side here, we know that that's just equivalent to 2 rad 5 times 2 rad 5. We can go ahead and pair up the 2's and say 2 times 2, which is 4. The square root of 5 times the square root of 5, well, we could say that that's the square root of 25, but we know what the square root of 25 is. It's going to give us a 5. So that entire thing simplifies to a nice and beautiful 20. So then right here, 20 plus 5. So therefore, square root c is equal to 5. Alrighty. We're hitting the home stretch here. Just got a couple more towards the end. Mostly the mid-segment and centroid stuff. But again, the whole deal is we're still working with properties of triangles. Solve for x. This should look awfully familiar. We have a perpendicular bisector. Now the nice thing about this perpendicular bisector is that since it's going through the top, this is actually cutting our triangle into 2 equal pieces. So in other words, these 2 sides must be congruent to those 2 sides. So we can say 5x minus 8 equals 3x plus 24. So I can add 8 to both sides. I can also take away 3x from both sides. So then we get 2x equals 32. Divide both sides, then we get x equals 16. Okay. EF equals 8x plus 42. FG equals 15x. Okay, so if we look at this picture, we're talking about this side and this side respectively. Now the reason we know that they're going to be equal is because we have an angle bisector in that corner cutting the 2 sides in half. But the kicker as well is not just because of the angle bisector, but it's because of what's happening here with our perpendicular lines. Since they're perpendicular, they're going to be forced to meet at a point that's equidistant from them. So therefore, these 2 will be equal. So again, just like before, we're going to say 8x plus 42 equals 15x. I have the majority of my x's on the right side, so I'm going to take away 8x. So then I'm going to have 42 equals 7x. X equals 6. Alright. Got some more angle stuff. Now the difference between this one and the one before was that we said that since we had the angle bisectors, those sides were congruent with conjunction to the perpendicular lines. Here, now we're going backwards. Since those segments are congruent, since this line equals this line, and we have those right angles, that therefore means that this angle here is congruent to that angle there. So let's see here, TSQ, that's talking about the top one, QSR is talking about the bottom one, so we're going to say they equal each other. So then we're going to have 4x equals 16, x equals 4. Okay. Naming parts. Altitude. Altitudes, we look for the perpendicular, and we make sure that it goes through a vertex. So I see a perpendicular right here. I see that right angle. And I see, hey, it does indeed go through a vertex. So that means that line, AF, is our altitude. Angle bisector. Again, we're looking for the angle cut marks, which, look at that. Boom, boom. So that means our angle bisector is CE. Looking for our median, remember it comes from a vertex, it cuts the opposite side in half. Well, the opposite side being cut in half, we're looking for these markings. And there you go. Vertex to opposite side, cuts the two parts in half. So DB is our median. Now, is there a perpendicular bisector? Well, remember, for it to be a perpendicular bisector, first off, you need that right angle, but not just a right angle, you need that side to get cut in half as well. Well, unfortunately, they're not both on the same spot. Right here, that green line that we have does not have a right angle. So since there's no right angle there, that green line is not a perpendicular bisector. We have a right angle right here, but the problem is that this side and this side are not equal. There's no marking to indicate that they are. And since they're not, we have no perpendicular bisector. And again, you need to be able to tell me why or why not. That should say a why. I don't know why it says what. Okay. P is the centroid. Centroid, you should be thinking the 1, 2, 3 rule. If you don't remember the 1, 2, 3 rule, again, remember we've got our proportions. We have our short, we have our long, and then you have your total. So remember, the short has a part of 1, the long has a part of 2. If you add them together, you get 3. So that's why I call this the 1, 2, 3. Right here, AG is 21. So I've given you the total. I'm asking you to find both parts. So if I write those letters in that order, let's see here, AG. And then I place P somewhere in between those two. By looking at my image, I see, hey, A to P is a longer segment than P to G. Ah, nice job, Sam Esquives. You're so funny. So right here, we're going to place the P. And then we're going to say this is the long part. And this here is the short part. Now the total that was given to us was that it was 21. Well, if we want to go from the total to the short part at least, we have to divide by 3. Because again, everything's partitioned into thirds. Short part is 1/3, the long part is 2/3. So 21 divided by 3 is going to give us a nice 7. If we want to go from the short part to the long part, just multiply it by 2. And so then we go over here and we just label what we have. So AP is 14, and PG equals 7. Alrighty, EP is 13. So in the image, EP represents the short part of our entire line. Again, this was all that was given to us. But if I want to find PB and EB, we got to find those two parts. Well, going from short to long, we're going to go ahead and double it, just like we did before. So 13 times 2 gives us a nice 26. Now my total is just going to be 13 plus 26. So that's going to be 39. So we're going to go ahead and write that in there. So PB equals 26, EB equals 39. Last one, we've got CP. CP is the long part of our line. So we're going to go ahead and say that. I already used blue, green. Let's use black. So C to P is long. And then P to F is short. So CP we said was 6. Now going from long to short, you're going to divide by 2. And again, to get your total, 6 plus 3 is 9. All right. Home stretch. Got a 1, 2, 3, 4, 5 more problems. Yay. In our triangle ACE, I'm claiming that CF, AD, and EB are all medians. Well, why would I want to mention that they're medians? Well, if you remember from the notes, the definition of the centroid is the intersection of all medians. That means that point right there is our centroid. And we need that because then we know, hey, medians include our 1, 2, 3 rule. So let's label it out. So BG is our short part. BE is the total, and that's 54. So the only thing we were really given was that this was x plus 7. Well, let's ignore the equation for now and let's just pretend, hey, I want to find the short and the long piece. Well, the short side is going to be found by taking the 54 and dividing it by 3. So then I believe that's going to give us 18. My long piece, therefore, is going to be 36. All right. We still need to find x. But here's the nice thing. X plus 7 is equal to 18, because those parts are the same. So we're going to say x plus 7 equals 18. So then x is going to have to equal 11. Going back here, we found BG, because we kind of worked backwards. And then GE we found by doubling it. Looking at number 30, we've got this beautiful line here, and this beautiful line here. Now the markings that are off to each of the sides are telling me that B is exactly in the middle of those two, and that C is exactly in the middle of the right side. Well, if I connect the midpoints, I create the midsegment. So that means that for these types of problems, we always say that 2 times the short equals the long. Well, our short piece is this one here. So we're going to say 2 times 2x plus 10. Set that equal to 5x minus 5. So distributing, we get 4x plus 20, 5x minus 5. And then again, just working our way through and balancing our equation, we're going to get x equals 25. Now we're not done because it says find BC. So that means we're going to take 2 times 25 plus 10. We're going to find that 50 plus 10 gives us a nice 60. We're going to plug our value back into our equation. 31. Again, we're told that B is the midpoint and D is the midpoint. Since these are midpoints that are connected, we have created again the midsegment. So BD is our short side, AE is our long side. Solve for x. Don't need to plug it back in, so let's just go for it. 2 times the short and I'm going to set that equal to the long. So let's see here. If I take away 4x, and then I go ahead and subtract 4. Let me just make sure I copied that down correct. Yep. So then we have 6x equals 2. X equals 2, 6. But wait, we got to reduce that fraction. So x equals 1/3. Number 32, points B, D, and F. We have the midpoints connected, so again we're dealing with the mid segments. EC is 40. DF is 18. Now AC is what I'm looking for first. So that that blue line is going to match up with that blue line. Well, remember that we just simply double the short to get the long piece. So that's going to give us a total length of 36. FB is this inside line right there. We do the opposite going backwards. We're going to go this way and divide it by 2. So that means FB equals 20. (33), connecting all midpoints again. But wait, we got a lot of stuff going on, so let's make sure we label it. BA is 32. AH is 60. 3x minus 2 is SC. And then EC is 15. Now I know that's a lot of colors, but let's look for the ones that are even parallel, because those are the only ones that are going to matter to us. SC is the short side to the green line, to our BA. So if I say 2 times the short side, we're going to set that equal to the long side. So we'll have 6x minus 4 equals 32 after we distribute. We go ahead and add 4 to both sides. And so then we find x equals 6. And that's it. So I don't know if Elijah was the only one. I don't know if there's anyone else left in this chat. I looked at participants. I didn't see anyone besides me. So yeah. So I hope that was somewhat helpful to you guys. Again, your test is Friday, so you've got time to watch this video later if you need to. Email me, bug me on Friday if you have questions, which I'm sure you will, and that's totally fine. Okay? I wish you all the best of luck with your studying, and I will catch you all later. Have a good night.